Hello, I'm Dr. Buddhika Lenike. I'm talking about thermodynamics problem solving using thermodynamics first law, delta U is equal Q plus W. This is a thermodynamic first law. Delta U is internal energy, Q is the heat absorbed or heat release, W is the work done by the system or work done on the system by the surrounding. Before we move on to problem solving, it is important to know the sign convention. So, what are the signs for Q and W? You can see here clearly the heat absorbed, or we call endothermic processes. The sign should be plus, the positive value. And the heat release means the enthalpy value, the value should be negative for exothermic reactions. Heat release means exothermic, heat released to the surrounding by the system. And then work done on the system by surrounding. For example, we have a trapped air inside a movable piston containing cylinder. Applying a pressure on the piston, we can compress the gas inside the cylinder. So compression, that is work done on the system. We are adding something is positive, plus sign. On the other hand, work done on the surrounding by the system. This is like the expanding. Inside the gases trapped in the cylinder expand, increasing the volume. That is work is doing by system on the surrounding. The sign is negative. So you need this sign convention before we apply the thermodynamics first equation delta U is equal Q plus W. Now let's go and find out some examples. The first example is a sample of helium gas expand in volume from 1.8 liters to 6.5 liter at constant temperature. Now you need to calculate the work done against a vacuum, and the second part is against a constant pressure of 2 atm. Now, this is the formula for the work. Work is equal negative pressure P times delta V. Delta V is the final volume minus initial volume, the volume change. Now, if we calculate the delta V, the final volume is 6.5 liters and the initial volume is 1.8 liters. So, if you get the difference, it is 4.7 liter is the delta V. Now, for the part A against a vacuum. So vacuum means the pressure of the vacuum is zero. So if we apply this equation, work is equal negative pressure 0 times delta V, then 0 times any number is become 0. So there is no work against a vacuum. Second part, pressure is 2 atm and delta V is same 4.7 liters. So W is equal negative pressure times delta V is equal, this is 9.4 liter times atm. And you can see the sign, it should be negative. So negative work meaning is work is done by the system on the surrounding. Now how we can convert this liter atm into joules? This is the conversion, the equality. 1 liter atm is equal 101.3 joules. So using this equality, we can generate a conversion factor. 9.4 liter atm, if you multiply it by 101.3 joules, that become 950, or in scientific way 9.5 times 10 to the power 2 joules. The reason is the given numbers give in two significant figures, so your final answer into two sig figs. Let's move to the second example. A second example is a nitrogen gas sample is cooled and lost heat of 98 kilojoules. The gas contract, or we could compression, decrease the volume as it cools, and work done on the system equal to 34 kilojoules. So what is Q, W, and U? So when the gas contract, that means the volume change, final minus initial, should be negative value. Initially the value, larger value, but contraction or compression means volume decrease. The final volume is less value. So the result should be negative. And according to the W, the work is negative pressure times delta V. This is the equation. So negative, the pressure times delta V. If the delta V is negative, you can see the front negative sign already in the equation. Negative times negative become finally work positive. So work is plus 34 kilojoules. Uh, and then Q value, it's negative 98 joules. The reason is it says the gas cooled and lost heat 98 kilojoules. So heat release is negative 98. It's an exothermic process. Now we know the work is plus 34 and the Q value is negative 98. Let's apply delta U is equal Q plus W to calculate delta U, the internal energy change. So Q plus W, the difference is negative 64 joules. Kilojoules should be our answer. Third example, calculate Q value and determine whether heat is absorbed or released. So how we can determine the heat absorbed or released depends on Q, the sign of the Q. If we get the negative sign, the heat released to the surrounding. If we have Q after we calculate the positive value, heat absorbed reaction. Now, the further it says when a system does 85 joule of work on the surrounding, that means system is doing work on the surrounding is negative 85 joules of work. And the change in internal energy is negative 217 joules. So delta U is equal negative 217 joules. So let's apply the equation. The work done on the surrounding, that is a gas expansion, expanding the gas, that is piston is moving upwards, negative 85 joules, and delta U is given as negative 217 joules. So when applying the equation, negative 217 is equal, Q value we don't know, W is negative 85. So if we shift the negative value to the other side of the equal sign, it becomes positive. So the difference is negative 132 joules is our Q. You can see clearly it's negative. Negative sign means heat released to the surrounding. This is exothermic reaction. So our next last example is calculate the work W and determine whether work is done on the system or by the system. You can remember the sign convention. Work done on the system means like gas compression. It's decreasing the volume. So surrounding is doing or external pressure is doing work on the system. It is plus value. So work done by the system on the surrounding means it's like gas compression. The volume, the piston is moving up. The system released 308 joules of heat. The release means exothermic. It should be the negative 308 joules of heat. And delta U value is given as negative 233 joules. Now you know Q and delta U. Let's calculate W depending on the sign, and then we can determine is that work done by the system or work done on the system. So these are the values Q and delta U. Delta U value is negative 233 given in the question, and then Q value, its release means it should be negative plus W. So again, the negative number when we shift to the other side become positive. So the difference is positive 75 joules of work. So what is the meaning of this positive? Work is positive means the surrounding has done a work on the system. It's like gas compression. So now I hope you will have a better idea about thermodynamics first law applications in problem solving.
Thank you for watching. If this is helpful, please subscribe the channel and comment any specific area if you need to discuss and share with your friends.